Hello and welcome to this lesson on loci and path problems. By the time you finish this video, you will be able to: first, identify what a locus represents in geometry. Second, construct common loci using a ruler and compass. And third, decide whether to shade inside or outside a circle based on the condition given. Let's get started. Here are the 4 common types of loci you need to know for exam questions. First, distance from a point. If a point must stay a fixed distance from another point, the locus forms a circle. Every point on the circle is exactly the same distance from the center. Second, distance from a line. If a point must stay a fixed distance from a line segment, the locus forms a running track shape. It has 2 straight parallel lines and curved ends. Third, equidistant from 2 points. If a point is the same distance from 2 points A and B, the locus is the perpendicular bisector of the line joining them. This line crosses the midpoint at 90 degrees. Finally, equidistant from 2 intersecting lines. In this case, the locus is the angle bisector. Every point on this line is the same distance from both lines. These 4 loci appear frequently in GCSE questions, so recognizing their shapes is very important. Let's learn how to know which region to shade. In inside or outside a circle. First, let's look at distances from a point. If you are asked to show the region within a certain distance from a point, you draw a circle using that distance as the radius. Then you shade inside the circle. This represents all points that are closer than that distance. But if the question says more than that distance, then you shade outside the circle. Think of the circle like a boundary. Inside means close, outside means far. Now let's compare distances between 2 points. To find the region closer to one point than another, start by joining the 2 points with a straight line. Next, draw the perpendicular bisector. This line splits the space into 2 equal regions. Every point on one side is closer to point A. Every point on the other side is closer to point B. So if the question asks for the region closer to A, you simply shade the side that contains point A. Now let's look at lines instead of points. If you are comparing distances to 2 lines, the lines must meet at a point. Then you draw the angle bisector between them. This bisector divides the space into regions where each side is closer to one line. So if the question says, closer to line AB, you shade the region on the side of the angle that includes that line. Now here's where things get interesting. Multiple conditions. You must handle one condition at a time. For each condition, mark the correct region with a tick. Mark the incorrect region with a cross. Keep doing this step by step. At the end, only shade the region that has all ticks and no crosses. It is like solving a puzzle. Only the region that satisfies everything survives. Now let's dive into some exam-style practice questions. You can pause the video and try it yourself. We are asked to show the region inside triangle PQR that is closer to side PQ than side PR. So imagine the triangle like a small map, and every point inside it is choosing which side it prefers to be closest to. Our job is to draw the boundary that separates those choices. First, place your compass at point P. Open it to a reasonable width. Not too small, not too large. Draw an arc that cuts across both sides of the triangle, crossing PQ and PR. What you've just done is mark 2 points that are the same distance from P. Think of it like placing 2 identical footprints on each side. Now, without changing the compass width, move your compass to the point where the arc crosses PQ. Draw another arc inside the triangle. Then repeat the same step from the point where the arc crosses PR. Draw a second arc, again without changing the compass width. Now look closely. These 2 arcs will intersect at a point inside the triangle. That intersection is very important. It is a point that is equal distance from both sides of the angle. Now take your ruler. Draw a straight line from point P through that intersection point. This line is called the angle bisector. It splits the angle at P into 2 equal parts. But more importantly for this question, it creates a boundary. Every point on this line is exactly the same distance from side PQ and side PR. Now we decide which side to shade. The question asks for the region closer to PQ than PR. So look at the triangle. Find the side PQ, and then look at the region between PQ and the angle bisector. That is the region we want. Now shade that area clearly. Every point in the shaded region is closer to side PQ. If you picked any point there and measured the shortest distance to each side, the distance to PQ would always be smaller than the distance to PR. So to summarize the thinking behind this, the angle bisector acts like a fair dividing line. On one side, points prefer PQ. On the other side, points prefer PR. And right on the line, they are perfectly balanced. That is how we identify and shade the correct region in this type of locus question. Let's move on to another problem. You can pause the video and try it yourself. An emergency alarm system operates between school X and school Y as shown on the scale diagram below. The alarm will be triggered from tower P if one of these conditions is met. First, the location is closer to school X than school Y. Or second, the location is more than 4 kilometers away from tower Q. Now let's work through this carefully. In this problem, we need to decide whether the emergency cabin will activate the alarm at tower P. To do that, we must check each condition one at a time and see if the cabin satisfies at least one of them. Let's begin with step 1. We need to check if the cabin is closer to school X than school Y. Start by taking a ruler and drawing a straight line between school X and school Y. This line represents all the direct distances between the two schools. Next, take your compasses and open them to more than half the length of that line. Place the compass point on school X and draw an arc above and below the line. Without changing the compass width, move the compass to school Y and draw another pair of arcs. You should now see 2 intersection points where the arcs cross. Now take your ruler and draw a straight line connecting those 2 intersection points. This line is called the perpendicular bisector. Here's why this line is important. Every point on this line is exactly the same distance from school X and school Y, so this line acts as a boundary. On one side of the line, all points are closer to school X. On the other side, all points are closer to school Y. Now look at the position of the cabin. The cabin lies on the side of the bisector that is closer to school Y. So this means the cabin is not closer to school X. So we can conclude that the first condition is not satisfied. Now let's move on to step 2. We need to check if the cabin is more than 4 kilometers away from tower Q. We are given a scale where 1 centimeter represents 1 kilometer. So 4 kilometers will be represented by 4 centimeters on the diagram. Take your compasses and set the width to 4 centimeters using a ruler. Then place the compass point at tower Q. Now draw an arc or a full circle around tower Q with that radius. This circle represents all the points that are exactly 4 kilometers away from tower Q. Now think about what this means. Any point inside the circle is less than 4 kilometers away. Any point exactly on the circle is exactly 4 kilometers away, and any point outside the circle is more than 4 kilometers away. Now check the position of the cabin again. The cabin is clearly outside this circle. That means the distance from the cabin to tower Q is greater than 4 kilometers. So the second condition is satisfied. Now let's bring everything together. The cabin does not satisfy the first condition because it is closer to school Y than school X. However, it does satisfy the second condition because it is more than 4 kilometers away from tower Q. Now pay attention to the wording of the question. It says the alarm will be triggered if one of these conditions is met. This is very important. It means we only need one condition to be true, not both. So even though the first condition is not met, the second condition is enough.